start, remember I told you, what day did I see y'all last? Friday. That we were going to get into a little bit of probability. That whenever we were doing combinations, we were just talking about possibilities, but we were going to get into probability. Do y'all know what probability? By the way, this is 6-2. Probability distributions. Well, if you're looking at the probability of something, then what are you?
It would be something that may happen. Like.
So if I said.
If you have a 6-sided die, like what's the probability that you would get a 1?
And what would the probability be?
1 out of 6.
1 out of 6. So what you're really doing is.
Ratio.
It's a ratio. You're exactly right. And that ratio consists of all the total possibilities, right? You could get that don't look right. Possibilities. Is that right? That looks awful strange.
No, there's not one. There's one S. Posibility.
Oh, no.
That looks like too many eyes to me. Okay, so possibility.
2 is a possibility.
Over what you're the top number is how many meet a certain criteria, right? So it's hard. I'm trying to think how to put it in words the best. So in other words, if you're talking about what's the probability, like Juliana said, if you've got a 6-sided die that you roll, what's the probability that you get a 2? Well, how many meet that criteria? One thing out of how many in total? 6. And this is going to be where those combinations start coming into play too. Okay, so a couple of things about probabilities. Y'all got that? Mm-hmm. Probabilities. Oh, probability. What do you know that it can never be?
0.
It could be 0. You could have a 0 chance.
You could have no red in that.
You could.
More than
what? More than the total, so that would mean more than what?
More than
6. So if it's 7.
Think about the probability. If it's a ratio, it can also be a percent. Yeah, you're right. Okay, so never, we'll do that one first. Never a negative. There's not going to be a negative 25% chance that you roll a 6, right? What else can it not be? Over 100%. So never over 1 if you're talking about ratios, 100% if you're putting it into a percentage. So what we're going to do, huh?
You can never have more than 1.
It can never be over 1. The probability of any one event occurring can never be over 1. Because there's not going to be 115% chance that you roll a 6 or that you roll any number on a dice or anything. With probability, your things that meet your criteria can't be more than the possible combinations, if that makes sense. All right, so here's what we're going to do. We're going to make what we call a probability distribution. Probability distribution. And what this does is this lists out all possible scenarios in happening. It just slipped.
I thought it was like a keyword.
It's going to look like this. Okay. X is the variable, just a random variable that I let represent my scenario. And I'm going to set this up as a scenario in just a minute. And this is the probability of each of those events occurring. So, for instance, I have 2 dice. Okay, I'm going to roll those 2 dice. I want to know what the probability, I want to construct a probability distribution of the sum of those two dice when I roll. So we need to think about, well, what are the possible outcomes? What could I possibly get? If I'm talking about the sum of two regular six-sided dice, what could I possibly get when I roll two? As far as the sum goes, that means adding the two together. 2 through 12, right? Does that make sense to everybody? Huh? If you're rolling two dice and you're adding what you get together, be 2 through 12, right? I'm not going to have room. Pooh! I'm going to the next page. I'm going to do it again, but smaller. What you tired of? Don't answer that question. Okay. So we all agree that's every possible outcome for my random variable. That represents, okay. So now what I want to know is what's the probability or what are the chances that I get a 2? And you can do it in a ratio form or a percentage form. How many different combinations of dice could you get? That's what you got to figure out. The only way to get a 2 is if you roll a 1 and a 1, right? But how many different scenarios are there?
A lot.
A lot? So let's think about it. Dice 1 or die 1. Which one's plural? Dice is plural. Okay, so die number 1. I could get a 1, 2, 3, 4, 5, or 6. Do you all agree with that? Die 2. If I roll a 1 first, the second die could be 1, 2, 3, 4, 5, or 6. Do you agree? If I roll a 2.
Why?
Well, the second dice could be anything at all. Think about it. If I'm setting up every possible scenario that could happen. I could roll the first one could be a 1. The second one could be anything. If the first one's a 2, what could the second one be? A 1, a 2, a 3, a 4, a 5, or 6.
So that's the same for everything then.
Exactly. Oh, you can't see it. It's off the page. It's there. Now it looks like 12, but. This one could be. But this is not the question I asked you. I asked about the sum of the two dice. So let's look at our scenarios. For the sum, if I rolled a 1 and a 1, the sum would be 2. If I rolled a 1 and a 2, the sum would be, can y'all see that too? Nope. A 1 and a 3 would give me a 4, 1 and a 5, 1 and a 6.
Oh.
Ah, I sure did. Thank
I
you.
was gonna say, wow,
Now let's move on to the 2. 2 and 1, so it'd be 3, 4, 5, 6, 7, 8. The 3.
4.
The 4.
5, 6, 7, 8, 9, 10.
The 5.
7, 8, 9, 10, 11.
And the 6. Is anybody confused? Do you see what we did? I just set up, this is what they call a probability tree. I'm just basically setting up all the possibilities. If I couldn't figure it out in my head, I'd need to set up something to show me. So how many in total possible combinations of rolls are there? 36. Do we all see that? There are 36 different scenarios that could happen.
Because 6 times 6.
So everything is going to be over 36.
Pretty sure right down at the bottom, 36 possible.
That's your total possible, yeah. So now the question is, of those 36 times, how many times does 2 occur? 1. The probability that you roll 2 dice and you get snake eyes is 1 out of 36.
And then the next one's going to be 2 out of 36.
The next one absolutely is 2 out of 36, and if you want to reduce that to 1 over 18, you can. It doesn't have to. Sometimes it's easier if you leave them in the common denominator so you can see. Oh my goodness.
What's snake eyes? I don't know which one it is.
2 ones.
The next one's going to be 3.
The next one's going to be 3, so if you reduce that, it would be 1/12. How about 5? 4, and then 5 6s, and then what? How many 7s? 6. How about 8s? 5. How about 9s? 4. How about 10s? 3.
This reminds me
11s.
of the triangle.
And there's a lot of things that come into play here. If you're looking at this, understand what this is telling you. This is telling you the chance that you have of rolling a certain sum. Okay? So if you're, well, y'all, we wouldn't gamble, but let's say we were, we wanted to pick the most likely scenario. Okay? Which one would we pick? 7. 7's the most likely to occur. Do you agree? Do you see why?
You would have 6.
1/6. What's 1/6 as a decimal?
Point
Is it? No. What is it? 6 goes into 1. Okay. So you have roughly a 16.5% chance of getting a 7 when you roll, which is the best one you have, the best chance you have getting. And whenever I say number, I'm talking about the sum of the 2 numbers. Does that make sense to everybody? No. Who said no? Oh, okay. Yeah. That is how many times these occur in this little scenario that I set up here. So 2 happened only 1 time in all those white numbers. 3 happened here and here, but never again. So 2 out of the 36 scenarios. Does that make sense?
How you got the 36 again? I forgot.
Count all those white numbers and there's 36 different possibilities. Couple things. If you do this correctly, and your variable is every possible outcome, which is the way you have to do if it's a true probability distribution, then what should your probabilities all add up to? 100% or 1. Why?
Because that's all the possible probabilities.
That's every possible scenario. If you list every possible scenario and you add your probabilities up, well, if you roll 2 dice, there's a 100% chance that you're going to get a sum between 2 and 12. There's nothing else to get. You've included everything. Does that make sense? All right. So, let's look. What if... Huh? No. All right, so we're going to do these probability distributions, but then we're also going to graph them. Oh, no. Y'all, come on. It's not even hard. Probability distributions. I'm going to stick with PROB since I can't seem to spell. It's a histogram. This is my variable down here. That's my possibilities. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Here, my my y-axis is going to be my probability because probability is never negative. I don't have to include the bottom portion. And because to the right...
On the problem before?
Yeah. Histograms are easy. If you can't graph a histogram, come on now. All right, my probabilities ranged from 1 over 36 to 6 over 36, right? I'll just go up by 1/36. What was the probability of rolling a 2? 1/36. How about a 3? 2/36. How about a 4? Is there anything hard about this?
Are we going more in depth with this?
Not the histogram, no.
The other part?
Yes, we're going to do binomials.
What is that?
What do you notice about my histogram?
It's like a staircase going up and down. It's like
I'm looking for a particular word.
organ. Like it's a little thingy.
An organ, it
It's
does.
like a little thing.
Give me a geometrical word.
Triangle.
Another one. Symmetrical. That's what I was looking for. It's symmetrical. Is it easy to tell looking at the histogram what the most probable event is?
It's like a Christmas tree.
Yes, it's the tallest bar. The 7. Does that make sense to you?
I think he just wanted to do a Christmas theme lesson.
Tell me this. Let's use these two things to answer some questions about. Let's see how well you understood the and the or stuff also. Using, y'all got this? Can I? Okay, tell me when you got it. Okay, looking at this probability distribution, we talked about the most probable was 7 with a 16.6% chance of occurring. What is the probability that your sum, and listen carefully, is at least 10? What's the probability that your sum is at least 10? Is that greater than or less than 10? Greater than 10. So greater than or equal to 10. So what's the this is how we'll write it. What's the probability that the sum is greater than or equal to 10?
But you just told us that the sum couldn't be greater than 1.
No, what?
She's talking about
Okay.
Over 1, that's what I thought of.
3, 5, 6. Bless you. Does that make sense?
No.
Miss McGee.
What do you, what?
What's the probability? What's the probability that it's at least 10? That means it could be 10 or 11 or 12. And or means add. Yes?
Yes.
What's the probability that you get
So 3 36 plus 2 36 plus 1.
Hey, I got one.
that you get at most 7? So you did the probability that x was less than or equal to 7, yes? Do you see where we're going with this? See what we're doing?
I don't
Easy.
understand. How did you get 21 36?
Less than or equal to 7, so we added all of these together. From 7 below.
This is the kind of math I'm good at.
Let's see, Tanner.
I'm talking about like easy math. I'm really good at that. Like that's my area. That's why I understand chemistry.
You take a quarter.
Okay.
And you flip it 2 times. What's the probability that you get heads on both flips?
25%.
How are you doing it? What do you do?
What? You right?
What when I say a 4?
Let's set up a probability distribution. And let's see. We'll let X be the number of heads. If I'm flipping twice, I could get no heads, 1 head, or 2. Do we agree? Okay. So let's think. First coin, I could get heads or tails. Do you agree? Second coin, I could get heads, tails, heads, tails.
Why?
Those are the only 2 options.
Is it plus the second coin? You mean?
No, I'm not adding this time. This time I'm talking about setting up scenario. Let's make it even more interesting. Let's say 3 flips. Okay? So with 3 flips, I could get up to 3 heads, right? So this is coin 1. This is coin 2. Coin 3. Here. Does that make sense? I'm just listing out possibilities. How many scenarios? Understand what this is. This is saying I could get a heads, heads, heads. Because I'm flipping 3 coins. I could get heads, heads, tails. I could get heads, tails, heads, girls. I could get heads, tails, tails. Or I could get tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. Those are all the different possibilities when you flip 3 quarters.
Wait, are you trying to get 3 heads?
That's what I'm doing. I'm creating a probability distribution for the number of heads that I get whenever I
I just
flip.
kind of don't understand how the coin number 2.
Y'all gonna be asking all kinds of questions and you're not paying attention. That's a problem for me, okay? Say it again.
I don't understand how the head number, like the second coin,
Mm-hmm.
we get a head and a tail and a head and a tail.
It's saying it could be either one. You're setting up scenarios,
Okay.
okay? So,
So for each tail, you could get a head.
correct. So this is coin 1. Think of it maybe not as 3 separate coins flipping. Think about taking 1 and flipping it 3 different times. You flip the first one, you're either going to get a heads or a tail. Okay? When you pick it up and flip it again, if you got a heads the first time, what could you get when you flip the second time? Heads or tails. But if you got a tails, what could you get the second time? Heads or tails. So every time there's 2 more scenarios on each one building, which is why we're branching off that one. So now, does it? Okay. So how many different scenarios do I have? 8 different scenarios. My total is 8. Heads, heads, heads.
Okay.
Heads, heads, tails. So there's 2, 4, 6, 8. Of those scenarios, how many scenarios will you not get a heads at all? 1. That's when you get tails, tails, tails. Okay? How about, how many scenarios do you get 1 heads?
The 1. Wait, no.
2.
2.
Tails, heads, tails, or heads, tails, tails. So 2. How many scenarios do you get 2 heads? And how many scenarios do you get 3 heads? 1. So, if you were a betting person, what would you put your money on? 2. Most probable is 2, right?
Because it's 1.
If you flip 3 coins, that's the most probable. Does that make sense?
I guess.
What's the probability that when you flip them, that you get at least 2 heads?
That doesn't add
2
up
and 4,
to
10.
The second one's 3, right?
Oh! So 1 and 2 are the most probable. I'm sorry. Yes, but that's a great catch because that's what we always check with distributions is that they add to 1. What's the probability that you get at least a 2? 1/2. 50%. 3 and 4, these 2 together would be 4/8, which would be 50%. There's a couple in your book that you're going to have for homework that I want to help you interpret because they always, always, always stump students. Number 3 says, I'm not going to set up the distribution for you. I'm just going to help you figure out what it is they're asking you.
So 3 and
This is number 3 on page 391. It'll come from your homework. X equals the number on a table tennis ball randomly chosen from a bag that contains 5 balls labeled 1, 3 balls. Hold on. I got this bag. That's my
I
bag.
love that bag.
5 balls labeled 1. 1, 2, 3, 4, 5. These all have a 1 on them. 3 balls labeled 2. And 2 balls labeled 3. 5 balls labeled 1, 3 balls labeled 2, and 2 balls labeled 3. Ah! Thank you. And it asks you to construct a probability distribution. X is the number on the ball.
so 2 out of 10 chance of getting that.
So it asks you to do a probability distribution. So my question is, what are your possibilities? Your X, if X is the number on the ball, what are your possibilities? When you pull a ball out, what could you possibly get?
1, a 2, or a 3.
A 1, a 2, or a 3. You should be able to set that up from there. Okay?
And then
Number 4 says W equals 1, and listen to this carefully. If a randomly chosen letter is A, E, I, O, or U. W equals 2 if it's anything else. Write a probability distribution about randomly picking a letter.
So you would have to pick between A and
What's your possibilities? W is your variable.
I like that.
What are your possibilities? What could you get?
I definitely think
A 1 or a 2.
why? Oh, because W.
W equals 1 if it's A, E, I, or U, and it's 2 if it's anything else.
A-I-U.
You're going to have to do a table and a histogram for these, okay? Number 5. Probably the one you really have to think about the most. If n equals the number of digits in a random number from 0 to 999. That's all it says. Make a probability distribution, randomly choosing. How many, or what are my n's? 1, 2, and 3. How many one-digit numbers occur between 0 and 999?
Oh.
How many two-digit numbers occur, and how many three-digit numbers occur? Does that make sense to
So
you?
like 1 over 99.
Over 1,000. You're counting 0 in these. Zeros included. Right, 1 to 999 would be 999 numbers, but 0 to 999 is 1,000 numbers because you're including 0.
Okay, so number 1 would be 1 over 1,000.
How many one-digit numbers? So you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once you hit 10, you're into two digits.
Okay,
Wow.
so then 9.
Never heard you say that.
What did you say?
Crap.
Crap.
So then it's going to be 1 over 10. Right?
It would simplify down, yeah. No, 1 over 100, because it would be 10 over 1,000. Should be 1 over 100. All right, that's all I got for today. I'm not going to get into binomials today.